All right, welcome to lesson 2 of module 1. The objective for lesson 2 is to reason abstractly using place value understanding to relate adjacent base 10 units from millions to thousands. Reason abstractly means now we're just going to be relying more on just numbers. Now we're not going to use concrete drawings or manipulatives. We're just going to deal with numbers. All right, now starting with 1A. We can see that this is 36,000 times 10. Now we know a lot of times they say, well, you're just adding a zero, but we've proved now that that is not exactly the case, because if you're multiplying a decimal by 10, then if you add a zero, you haven't changed the value of the number. So the correct thing to say is that all the digits are going to shift one place value to the left because they're going to go 10 times greater. So 36,000 times 10 is going to end up with 360,000 because each digit shifted one place value to the left. B, now we're showing that 36,000 divided by 10. So we know it's going to be going to a smaller number. Since the digits are going to be going to the left one position, we know we're going to lose one of our zeros because it's going to shift to the 1/10th position, which we wouldn't show anymore. So at this point, we would end up with 3,600. 4 3/10 times 10. Now this is where I was talking about before. Now this is the biggest misconception. If I have 4 3/10 and you're telling me that all we're going to do is add a zero to the end of it. I added a zero to the end of it. Now it's 4 30/10. Well, 4 30 hundredths. 4 30 hundredths is equal to 4 3/10. So we haven't changed the value. So in order to change the value, the digits had to shift to the next place value. So the 4 who's in the 1's position goes to the 10's position. The 4 that was in the 10's position goes to the 1 position. And now we have 43. In the same instance, we have 4 3/10 divided by 10. Well, to be reasonable, we know our number is going to get smaller. So when we multiply, our digits move to the left. So when we divide, our digits are going to move to the right one place value. So since they're both moving to the right one place value, we're going to end up with 43 hundredths. Now E up here was done for us. It says 2 4/10 times 100. And we know 100 is actually 10 times 10 and when you decode it. So we know that's 2 place values. So the digits are actually going to move 2 place values now. And since it's actually the digits are moving to the left, we can see 2 4/10. When we move it to the left, that's 1 position, 2 position, and fill in with zeros. And I always like making that new decimal point real big so I can see it. So now we can see that 2 4/10 times 100 equals 240. Now 24 divided by 1,000. We know the digits are going to shift, but we've been talking digits. Let's start talking about decimal points now, because if the digits go to when we're multiplying, like up here, the digits went to the left, the decimal place went to the right. And you have to be real careful on how the question is. The question asks in which direction the digits are going or which direction the decimal point is going. So here, the way I always keep it straight is 2.4 times 100. I know my digits are going to go to my left, so my decimal will go to the right. On the next one down here, 24 divided by 1,000, I know that if I multiply, my digits would go to the left. So since I'm dividing, my digits will go to the right. It means my decimal is now going to go to the left. So if I started with 24, and I know the decimal is right after the one's position, and I know it's going to go to the left, and 1,000 means 3 positions, because that's going to be 10 times 10 times 10. So we're going 1, 2, 3 positions. Make that big decimal point, and I have to put that placeholder in there. So we know that 24 divided by 1,000 is equal to 24 thousandths. Next, we have 4 and 54 hundredths divided by times 1,000. Now we know the digits are going to move to the left, so the decimals are going to move to the right. So 4 and 54. We know 1,000 is 10 times 10 times 10, so it's going to be 3 place values, and it's going to go 1, 2, 3. Make that big decimal, put in our placeholder, and now we know that it is 4,540. In the next and last problem, we have 3,045 and 4/10 divided by 100. So I'm going to go ahead and write it over at 3,045 and 4/10. Now it's dividing, so I know if I multiply, the decimal is going to go to the right. So dividing, it's going to go to the left. And I know it's going to go to left 2 positions because it's divided by 100. So I'm going 1, 2 positions. So our answer would be 30 and 454 thousandths. Okay, question 2. Find the products. Now, the products, we know, are an answer to a multiplication problem. You have to be very good with those terminologies. So question A says 14,560 times 10. Well, I know in this case that the digits are going to shift to the left. That means the decimal is going to shift to the right 1 position. So I have 14,560, and when the decimal shifts to the right, I'm going to add 1 more 0, and we end up with 145,600. The same number multiplied by 100, and we know that's 10 times 10, so that's 2 place values. So I'm going to go ahead and write my digits in, and I know it's going to the decimal is going to move 2 places to the right, and I'm going to have to add zeros. We end up with 1,456,000. On C, we're actually multiplying by 1,000 this time, which is 10 times 10 times 10, 3 place values. So I'm going to go ahead and 560, my decimal point's right here, and I know the decimal place is going to move 3 places to the right. 1, 2, 3. Make that big decimal point, and I'm filling in the placeholders. So now I know that the answer, once I fill in my periods, would be 14,560,000. Find the quotients. Okay. Remember, it's always good to have a reference, and I always use multiplication as a reference. So we're starting at 1 and 65 divided by 10. Well, I know if I multiply by 10, my decimal would move to the right. Since I'm dividing by 10, my decimal is going to move to the left. So I end up with 1 and 65, and it's going to move to the left 1 position because I'm dividing by 10. So I know my answer would be 0 and 165 thousandths. In this case, we're dividing again, we're dividing by 100, which is 10 times 10, 2 place values. And once again, we know we're going to be moving to the left. So we have 1 and 65, and we're moving to the left 2 place values. That's 1, 2, make the big decimal point, place my placeholder, and now we know the answer is 160. Actually, that'd be 165 10,000ths. C. Explain how you decided where to place a decimal in the quotients A and B. Well, in A, we knew that since we were dividing by one place value, we're moving one place value. And since we're dividing, we were moving to the left. In B, it was 100, so we knew it was 10 times 10, so we knew we were going to move to the left 2 place values. Question 4. Ted says that 5/10 multiplied by 100 means 300 thousandths. Is he correct? Use a place value chart to explain your answer. Okay, so let's go ahead and draw ourselves a place value chart. And it says 3/10 multiplied by 100, so we don't have to make a very large place value chart. I probably made it bigger than I needed because we know this is the 1 1,000ths, the 1 100ths, this is a 1/10, and here's our 1 place. Put another one out there. This is our tens place. So it says 3/10, so I know I'm going to put 3 in the tens place. And it says that if I multiply it by 100, okay, so if I multiply it by 100, which we know is 10 times 10, that's 2 place values. If we multiply it, we know our digits are going to move to the left. So that means it would move to the left 1, 2 place values. And we can see that 3/10 times 100, 3/10 times 100 would actually equal 30, not 300 thousandths. So he is not correct. Question 5. Alaska has a land area of about 1,700,000 square kilometers. Florida has a land area that's actually supposed to be 1/10 the size of Alaska. What is the land area of Florida? Explain. Well, if I want to know what 1/10 is, I would take 1,700,000, 1,700,000 times 1/10. Okay. Now, if I'm multiplying by 10, if I were to take the same number and multiply it by 10, the decimals would go, the digits would go to the left, and we would end up with 1, 2, 3, 4, 5, 6 zeros. But we're multiplying by a fraction that is less than 1. So instead of moving to the right, to the digits moving to the left, the digit is going to move to the right. So, and that is because multiplying by 1/10 is the same as dividing by 10. Okay? Because this one here is called the inverse. Of 1/10 will be the inverse of 10. Okay? Or opposite. So in this case, we know the digits would actually move to the right, and we would end up with 170,000.